Hello, this is Mr. Win, and this video is over quadrilaterals part 2. We'll be going over rhombi and squares. Rhombi is the plural form of rhombus. So here's our flowchart from 4. Last time we already did quadrilaterals, well, part of them, where we did parallelograms and rectangles. Now we're going to do the next two shapes, the rhombus and the square. So a rhombus is a quadrilateral with 4 congruent sides. That means all sides are equal. So there's a picture of a rhombus, looks like a diamond. Important properties, all quadrilateral properties are maintained, so it still adds to a 360 inside. Both parallel sides are congruent. Each side is equal to the side across from it. So say if this is 20, and this opposite side is also 20, but actually all sides will be 20. Alright, both pairs of opposite angles are congruent, so opposite angles are equal. So if I say this is, let's make some up, let's say this is 40 degrees, this is also 40 degrees, and this will be 140, this will be 140. Alright, consecutive angles are supplementary. Again, supplementary means add up to 180. That should be true. 40 plus 140 is 180. Diagonals bisect each other. So I drew the diagonals. Let me use a blue line. This diagonal and this diagonal, they cut each other in half. So I'll use blue still. So this piece matches this piece matches this piece, whatever they are. All right, notice those properties were actually the same properties as a parallelogram. So since all parallelogram properties are maintained, every rhombus is also a parallelogram. But again, not the other way around. Not all parallelograms are rhombuses, just rhombi. From the last video, you saw that some parallelograms are rectangles. And even some parallelograms are neither rectangles or rhombi, just a regular parallelogram. All right, we have two new properties. Diagonals are, the new word is going to be perpendicular. Perpendicular means makes 90-degree angles. So if you look, these are vertical and horizontal. These are all 90-degree angles. So just all right angle boxes here. What else? Diagonals are angle bisectors. So they cut all angles in half. So for this top angle, I really said it was 40 degrees. I know that each piece is 20 degrees, 20 degrees. Same for the bottom, 20 degrees, 20 degrees. And for the side, it was 140, half of 140, 70. So here's 70, 70, 70, 70. Those are right triangles, you can tell. 20, 70, and 90 make 180. There's 4 right triangles in there. And when you see right triangles, you should think trigonometry is a possibility in Pythagorean theorem. So in the rhombus below, if the measure of angle GMO is 150, so let me label that. This whole angle right here is 150 degrees. And side GM is 40, so this is 40. Find measure of GYE, so let's just go in order. GYE, G to Y to E, they're asking for this angle right here. Well, that's the 90-degree angle because diagonals are perpendicular. Alright, so I'll say it here. So angle GYE equals 90 degrees. Alright, it says next find measure of angle YEG. YEG, where's that? Y to E to G is this top angle right here. We can actually find that. Remember, opposite angles equal. So if the bottom is 150, the top is 150, but we can half that and get 75 and 75. Alright, so G, let's see now, Y to E to G is 75 degrees. Angle Y to E to G is 75 degrees. What else are we asking for? Measure of EGY. EGY is the left angle. So let me erase this. Alright, so now they're asking for what is this angle over here. And that's we just do triangle sum. So 75 plus 90 plus, I guess, x equals 180. That gives us 15 degrees here. Those marks here. All right, so that was a pretty easy one. Angle EGY is 15 degrees. If you wanted to, actually, if that's 15, this bottom's also 15. Right? Then the whole thing's 30. These are 15s. So that's how a rhombus works. What else do they want us to find? If this is 40, we know this is 40. All sides is 40, right? All right, they're probably asking something hard next. Find E to M and G to O. E to M is actually this vertical diagonal right here. Right? So we see a right triangle. When we see a right triangle, think trigonometry. So I need to find the top piece, and remember the diagonals bisect each other. So whatever this top part is right here, that's the same as the bottom part. So let me look at this green triangle since I already have it. All right, I'm going to redraw it over here. So we know that this is 15 degrees. This is 40. Can we find the other two sides? Yes, let's call this A and B instead of using X and Y. We just use trig here. So I label my angle. I like starring it. H, I guess I should use A and B, that's right, HAO. To find A, the height, we're going to use sine. So sine of 15 degrees equals O over H. I multiply both sides by the denominator to get 40 times sine of 15 equals A. That's the exact answer. I'll type in my calculator in a second. Let's find the other one. To find B, we're going to use ka, which is a cosine. So cosine of our angle is equal to A over H. So that's going to be B over H is 40. Again, get rid of the denominator by multiplying both sides by 40. So I get 40 times cosine of 15 is what B is. All right, so I'm typing those in my calculator and see what I get. I should have had it ready. All right, wrong numbers. Let's see. All right, now I have the right numbers. 40 sine 15 is 10.3527. It says round to the nearest tenth, so that 5 does bump that up to a 10.4. So this A is about 10.4. And for the other one, 40 cosine 15, 38.637, keeps on going, but round to the nearest tenth. That 3 does not bump that 6 up, so about 38.6. B is about 38.6. All right, so I know this top piece is 10.4. That means the bottom piece is also 10.4. Add it together, 10.4 plus 10.4 is 20.8. So E to M is going to be 20.8 units, whatever that is. And the other one, we know that this and this are the same. They're both 38.6. If I add that together, 38.6, 30.6, let's see, that's 60, 76, 77.2. So G to O is 77.2 units. All right, so I answered the question. I found all 5 things. By the way, we could have done Pythagorean theorem after finding one of the sides because we had one leg in the hypotenuse. So that would have got you the other side. But that probably would have been more work in decimals. All right. Squares. Squares are quadrilaterals of 4 right angles and 4 congruent sides. Notice 4 right angles were also from rectangles. 4 congruent sides were from the rhombi we just did. There's a joke. They say that if a rhombi and a square, a rhombus and a square had a baby, it would be a, if a rhombi and a rectangle had a baby, it would be a square. It inherited things from both parents. So the properties here, since all quadrilateral properties are maintained, all parallelogram properties are maintained, all rectangle properties are maintained, and all rhombus properties are maintained. So all sides are equal to each other, opposite sides are equal, all angles are 90, opposite angles are equal. Diagonals, they do bisect each other from parallelogram. They do make 90 degrees. That's from the rhombus. They are congruent. That's from the rectangle, but also parallelogram. They bisect each other, but they're also the same. It's so much things. All right, so I'll just leave that alone. What else want to do? From the rhombus, the diagonals are angle bisectors. So if that's 90, this is 45, this is 45, this is 45, this is 45, 45, 45, 45, 45. And those are 45, 45, 90 triangles, and you know the patterns for that. Anyway, let's see what the problem is. Just in the square below, if IG is 8, fine, everything else. So here's I to G. If that's 8, then all the sides are 8. All right, all these angles are 90. And with a right triangle, and two sides are 8, this is a 45, 41, because actually these are 45, 45, 90. You should know the pattern, x, 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 x root 2. So this whole thing is actually 8 square root 2. If I want to half that, then I know each piece is actually going to be 4 root 2 and 4 root 2. Because 4 root 2 plus 4 root 2 is 8 root 2. And that's it. So all the sides, all the angles, each half of the diagonal, the entire diagonal, nothing else. So pretty simple. You could do trigonometry, you could do Pythagorean theorem if needed. That would have got you 8 root 2. All right, last slide. There's a flow chart from before. I color coded this time. There's something called always, sometimes, or never true. And because I color coded, I'll make it simple. If there's a link up, that's always true. If there's a link down, it's sometimes true. If there's no link, then it's never true. So let's try the first one. It says a parallelogram is blank a quadrilateral. A parallelogram is right here and is going up to a quadrilateral. So is a parallelogram always a quadrilateral? The answer is yes. All quadrilaterals have 4 sides. A parallelogram always has 4 sides, so that's going to be always true. That's A, because it's going up. But now let's reverse that. Number 2, a quadrilateral is blank a parallelogram. So now we're going down. We're starting from a quadrilateral. We're going downwards to a parallelogram. So is a quadrilateral always a parallelogram? No. Sometimes the quadrilateral is a trapezoid. Sometimes it's a kite. It's not always a parallelogram. But sometimes it is. So if it goes down, there's a link. If it's color-coded, using the red direction, I'll put a S here sometimes. Abbreviation for sometimes. All right, next one. A square is blank a rectangle. So starting at square, down here. Rectangle, we're going upwards. Red path there. If we're going up, there's an upwards link. That's always true. All squares are rectangles because all squares have 90-degree angles and everything, all properties rectangle has. Let's try reversing that. So rectangle is blank a square. We're going downwards using this red path. So are all rectangles squares? No. Only the ones that have equal sides. But most of the time, you know rectangles have different lengths and different widths. So this will be sometimes. So there was a link going downwards. Right, and then here's a weird one. It says a rhombus is blank a trapezoid. Where's a rhombus? Here's a rhombus, and here's a trapezoid. There is no path there. So the rhombus is on this branch, what's called the orange branch, and the trapezoid is on the green branch. Those are different branches. All right, so they don't ever connect, so that's never. All right, so that's never true. A kite is blank a square. Here's a kite on this solo purple branch, path, link, whatever you call it. Here's a square. Are they on the same color-coded branches? Answer is no. So this is never. All right, how about this next one? Rectangle and rhombus. Here's a rectangle. Here's a rhombus. Is there a path or color code that they connect to? And that's no, there's 2 different paths. That's why I separated the red and the orange paths. They're side by side, but they're never the same. A rhombus won't have 4 right angles, and a rectangle usually doesn't have all equal sides. Now, if it was a square, then it was, but if you just have the basic properties, they're not the same. So that's never, there's no link. All right, a square is blank a parallelogram. Starting at a square, we're going to a parallelogram. There's 2 ways. You can go this way. We're going this way. That's true. All squares are parallelograms because both pair sides are parallel. And the last one, a square blank quadrilateral. So square going all the way up to quadrilateral. That's true. All squares have 4 sides, so it has to be a quadrilateral. That's it for the video. Make sure you ask questions. Thanks for watching. See you soon. Bye.